Physical Science, Module 6b, we'll be talking about the Earth's mantle. Several words in this vocabulary. We have seismic waves, seismographs, the mohorivic, I can't say this, mohorivic, anyhow, this discontinuity, or MOHO for short, and that's why they say MOHO for short. Lithosphere, asthenosphere, and plastic rock. The Earth's mantle is directly under the Earth's crust. So in our last video we talked about the Earth's crust, and right below it is the mantle. We've never made direct observations of the mantle, but we've learned a great deal by indirect observation. In class, we'll be completing several experiments that will help us understand the mantle and core and make use of the fact that waves travel differently in different substances. When earthquakes occur, they emit vibrations called seismic waves. These seismic waves can determine scientists can use these waves to determine the speed of vibrations and how much energy is lost as the vibrations travel by using detectors called seismographs. So if you have an earthquake, from the epicenter of the earthquake come what they call P&S waves, and we'll learn about those more later. And they're just not in a local area. They travel right through the earth. And when you're in the upper layers, they travel more quickly. As they go through the center of the earth, they slow down because of the denser material. And the speed of the vibrations are affected by the type of substance, so the dense material can actually affect the speed of the waves. This helps scientists, the speed of the waves actually helps scientists measure the layers of the earth. The first scientist to link the fact that vibrations in the earth are affected by substances in the earth was a Croatian scientist named Andrija, and I can't pronounce his last name, but that's where we get Moho from. He postulated that many miles beneath the surface was a border beyond which the composition of the earth was much different from that of the earth's crust. This border is known as the Moho. This Moho marks the boundary between the earth's crust and the beginning of the earth's mantle. Our indirect observations tell us that the rock of the mantle is mostly silica, so it's similar to the rocks in the Earth's crust. The matter in the mantle is more densely packed than that of the crust, and the deeper you travel into the core, the matter becomes even more tightly packed. The temperature of the rock also increases the deeper you get. At the Moho, the temperature is about 1,000 degrees Fahrenheit, while the lower portion of the mantle gets as hot as 7,000 degrees Fahrenheit. The pressure on the rock increases the deeper you get. So not just heat, also pressure. The pressure is about 1.4 million times that of atmospheric pressure. And the fact that pressure and temperature increase as you travel deeper into the mantle leads to some very interesting effects. The upper part of the mantle is composed of solid rock. This and the crust above it are called the Earth's lithosphere. Below the lithosphere is a small portion of mantle called the asthenosphere. At the temperature and pressure found in the asthenosphere, rock is not completely solid. It's like very thick syrup flowing around the mantle. When subjected to abrupt force, it hardens into a firm solid. After the force passes, the rock returns to its syrupy state. Scientists call this plastic rock. So plastic rock is actually rock that behaves something between a liquid and a solid. And this picture that I've placed on here is from rock that's found in Hawaii. And they have this constant situation going on between lava flowing out of a volcano that's cooling and then reheating and cooling again. So it's always in a different state. Hope this defines a couple of the things that were in your book, and we'll be pursuing this further in the next video.